two different masses m1 and m2 are attached with the same string that is light, so we are not going to consider the mass of this string, as well as look at this, that the surface on which the m1 is moving is also frictionless, so there's a no friction. And the third thing, that the third assumption that we are going to take is about this pulley is frictionless, as well as we are not going to consider the rotational motion of this pulley. Okay, so the force in the string is a tension T, and in this question you have to calculate or you have to find out an expression for the mass m2. Okay, so first of all, let's start from the mass m1. As it is placed on a horizontal surface, so can I say the normal force on this, the normal force on this is equals to the weight of this, means m1g. So these two forces are balanced. So if these two forces are balanced, then the only force that is exerted or that is accelerating it is obviously this tension force, and its magnitude is t, and its direction is rightward, and it is also producing acceleration in this direction. But what about m2? M2 is accelerating downward. So students, this is an unknown mass that we have to calculate, but we also know that it is accelerating downward. And if you are choosing the upward positive and conventionally downward is negative, then obviously this, first of all, this is a larger force than this force. Okay, and its magnitude is tension T. So when you will apply Newton's second law for mass m2, so we see that it is accelerating vertically along y-axis, so fy is equals to may. All right, or you can say its magnitude is a. So what is the force? You can also write m2g minus t is equals to m2a. m2a. All right, we can also use the smaller symbols, as in the answers we see small symbols are used. Okay, and what is the equation for m1? Don't forget what I told you about this tension, that it is equals to m1a, that this is a force that is accelerating m1. So I have applied Newton's second law for m1, so we got T is equals to m1a. Let's write it as well here, so we are going to use it very soon. Okay students, so we have to find out m2, and m2g minus m2a is equals to 10. You see that there is a no acceleration given in the answer, so it means we have to eliminate it. And how can we eliminate? Rather than substituting the value for the tension, we can put the value of acceleration, so that will be t over m1. So I'm going to put the value here, m2g minus m2 into tension over m1 is equals to t. Okay, so now you can take this on the other side. All right, or in fact you should take m2 common, so what we will get, g minus t over m1 is equals to tension t. All right, now what is our next step? Let's take the LCM inside. All right, what it this will become, can I say it is gm1 over m1 minus t over m1. I hope you understand this step, because it will cancel out again, like it is not disturbing the balance of the equation. Okay, and this is equals to the tension T. Now we can also write it like gm1 minus t over m1. Okay, we wanted to find out the mass m2. That's why first of all, like, you can take all of these terms on the other side, it is in division, it's in denominator, you can multiply m1 on both sides of equation, so we will get m1t. right now it's multiplying, so you can divide this term on both sides. So this term I'm talking about, Okay, students, so finally, the unknown mass m2, what we got m1t over gm1 minus tension t. So hence, the option D is the only answer that matches with our calculation, and I hope you understand this question.